How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we're going to be doing a repair on a D10 blade tilt cylinder where I need to reclaim the bores and the thrust faces, and that means I get to test out two of our newest shop-made tools. So this cylinder is used to tilt the blade left to right on the dozer when it's being operated. Because they are right in the working area of where all the dirt and the rocks are, it is very common for them to wear out. The dirt or the rocks get down in between the two thrust faces, and while the machine is operating, it basically acts like a grinding paste and grinds it away. And over time, that leads to everything starting to loosen up, and then the pin isn't supported and it can break the pin or it wears out the bushes prematurely. And in a worst case scenario, it breaks one of the ears off the barrel clevis. So this cylinder is actually in for a complete rebuild. We are going to be replacing the barrel. On the inside of it, there is a lot of scoring on the bottom end of the barrel, but we're not going to be showing that because we do have plenty of that on our channel already. So today we're just going to concentrate on the other end. As you can see on this barrel, both thrust faces are pretty worn. The bearings themselves are in good condition, but because I'm going to be welding on the inside of the clevis, it will pull the two ears together. And if they pull too far, we're not going to be able to get the bushes back in there and then get the pin back through them. So we will reclaim those bores as well. So the first thing I need to do is remove these old bearings. There is a little bit of wear on the front and the back of them, and they are cheap enough. So what we're going to do is cut them out. See how the material's been rolled over it from when it's been operating?
Oh, it's trapped it in there.
Yeah. Now that I've got the bearings cut out, I'm just going to go in with a barrel grinder to clean up those bores and get them back to bare metal. Now that we've got the surfaces cleaned up, I'm going to go through and weld up the faces and the bores. And to weld it up, I'm going to be using ER70S6 in a 0.9. I'm going to be backing that up with Argo Shield Universal, and I'm going to run that at 19 volts and about 4.5 meters of wire a minute.
Oh, that'll be so hot. How you gonna? Oh yeah, we have a crane.
Again, I have a crane.
There we go.
Now that I've got that welded up, I'm just going to go back through the bores with the barrel grinder, and that's just to remove any weld spatter or bits of wire that have hung on, because that stuff can break inserts. And I'm also going to use a flap wheel on the inside to do the same. And because that's extremely hot, we're just going to let it cool down. Righto guys, so that has cooled down enough now. We're going to take it over to our Zayer and get it set up.
Oh, there we go.
Now that that's set up, I'm going to machine the bore, but before I do that, I need to find center. And because we can't use the bore to get center because of all of that weld material, I'm going to be using the bolt holes. Now that we've found that center, all I need to do is move the table across 60 mil, and I know that measurement will put us center of the bore. And to machine the bores, I'm going to be using a 75mm adjustable boring head attached on our shop-made extended arbor. And I'm also using an adapter sleeve so I can use the BT40 arbor in the BT50 spindle. So because this is the first time I'm using this extended arbor, I am going to take it a little bit easy on it to begin with. We're going to start out at 340 RPM at 14mm a minute feed rate and see how it performs, and then go from there. So that's the cleanup cut done on the first bore, but I am going to increase the feed rate from 14mm a minute up to 22. So everything is still working well, and I'm going to increase the feed rate again. For our next cut, I'm going to advance the tool 0.6 of a mil, which is going to be 1.2 overall. So So I am noticing I am getting a harmonic and a ripple in the surface finish. Because this is a finer cut, there's not as much pressure on the insert. So for the next cut, I'm going to decrease the RPM from 340 down to 288 and see if that makes it better. So I'm still not entirely happy with that surface finish. It could be a combination of the length of the arbor and the surface speed. So what I'm going to do is change the insert out to something my tooling supply recommended to me. It is a Palbert CCGT, and he sent them up as a sample so we could give them a go in the line borer and in the milling machine. So we're going to see how they go. So as you can see, that insert has made a massive difference to the surface finish. It is much better now. I think we found the happy spot for the arbor. Now we can take our final measurement so we can take our finishing cut. So that's measuring at 101. The measurement we're aiming for is 101.6. That's 0.6 to come out. So I'm going to advance the boring head, 0.3 of a mil. Righto guys, so that's our bores machined, and I'm very happy with the surface finish and extremely happy with how that arbor performed. In a real world, you would have done the faces first and then gone through and bored it so you could chamfer it when you were done. But because I made the arbors first, they needed to be tested first. So that just means I'll have to do an extra tool change after we cut the faces, which we're going to get set up to do right now.
That's a George. George! Hello!
George.
That looks like a baby. No, come back. I don't think that's our George. They look younger.
And to cut the faces, I'm going to be using the MOAC, which is our shop-made mother of all cutters. And as you can see, it's had the Tuff-triding treatment, and I think it looks way more awesome. So now we've got the MOAC installed in the spindle. Before we do any cuts, I need to reverse the spindle. We're going to start off nice and steady. This hasn't been tested at all. So we're going to start at 100 RPM and a very low feed rate, and we'll just see what happens. So I can hear and see that we've only got 3 or 4 inserts contacting on each rotation. I'm going to put that down to the Tuff-triding has warped the plate. I haven't had a job like this Tuff-triding before, and I didn't think it was going to be a problem, but it is still working, and we are taking a 1mm depth of cut. It's just disappointing that it didn't work out exactly the way I wanted it to.
So just the way. Oh, that's just the lowest spot.
Yeah.
Where it was all the way.
Now that's our cleanup cut done, I'm going to increase it to a 1.5mm depth of cut. I'm also going to slow down the spindle speed just a little bit, and I'm going to up the feed rate to see if I can get any more of those inserts engaging. So that's that face machined. It didn't come out silky smooth, but it is 100% better than what was already there. Now we can get on to machining the top face. So we've taken our first cleanup cut on the top face, and it is only cutting on about 3 inserts on this side, and on the bottom it was cutting on about 4 inserts on the opposite side, 180 degrees out from it. Although it's not working exactly the way I wanted it to, it is still working, and it is a lot faster than the original way we used to do it. But I really didn't think the Tuff-triding would cause the warp in the plate like this. So after I finish this job, I am going to go through the process of elimination and try and identify where the problem is, and hopefully get it working the way we'd planned. So I've taken a measurement, and we've got 1.5 mil to be machined off the top face. So that's both of our thrust faces machined. Although it isn't working exactly the way I wanted it to, I am still really happy with the results, and the surface finish is going to be more than acceptable for what this component is going to be used for. So now that part of the job's done, we're going to get the cutter out and set up the boring head so we can chamfer these holes. So that took about 2 minutes to change the cutter. Now we're ready to go back to boring, and that's one of the main reasons why I made it. I don't have to waste time to reset up the job or realign the head.
see how it goes with it. How much it's warm.
So that's all the machining done. I'm just going to run a tap down through those bolt holes just to make sure they're nice and clean. Righto guys, so that's this part of the job completed. Overall, I'm really happy with the end result, and it was about twice as fast as it would usually take, and that's thanks to our new shop-made tooling. And I am going to go through the process of trying to work out whether there's a way I can salvage that cutter, and if that doesn't work, I am going to make up a new cutter. It's only about $300 in material and a day's work, and we have all the tooling here ready to go. So that's it for this job. I hope you enjoyed seeing our shop-made tooling in action. Thanks for watching. Right, ready? Right. And all that's for is to remove the weld spatter and any daggy bits of wire. And then over time, that will lead to everything getting, oh, I can't say sloppy. And over time, that leads to everything starting to get loose. Now that we've got the bearings cut out, I'm just gonna go in with a barrel. Now we've got that set up, the first thing, now we've got that set up, oh my God.
Sure. So you're gonna break it. Maybe just don't walk in with that. Jesus Christ. Oh.
Hey mate, how are you? Oh, you
What?
ran out of gas.
Oh no.
For fuck's sake.
Your arm and hand.
It's wolf bones.
Hell?
Caliper.
Oh.
Righto guys, so that's this part of the job completed. Oh. Righto guys, so that's, oh my God, I did it again. Brain's doing other things. Righto guys, so that,
Righto guys. So
I got it. Righto guys, so this part,